Hey folks, it's good to see y'all again. I'm going to be recording a few practice problems here and there to hopefully help y'all out. Your first assignment for this week happens to be limiting reactants. This is mostly a review. I do know that not all of you are here for limiting reactants. The concept of limiting reactant is to convert one reactant into the other because you have two starting points and you're not sure which one it is. Once you convert one reactant into the other, you make a comparison. Do you have enough of this reactant or do you have too little? It's a logic problem. Once you determine the limiting reactant, you will always use the limiting reactant to solve for the remainder of the problem. Anything else that's being asked will always use the limiting reactant. Now, with these problems, I have a few issues, and I hope you'll bear with me. Number one, my document camera isn't the highest quality camera, and it's a little difficult to make it point down. The quality of the writing may not be the greatest quality overall. Bear with me, I'm just trying to do my best. So we're going to take a look at problem number 2 in your homework this week, and here we go. All right. For problem number 2, we have 1.85 grams of magnesium hydroxide reacting with 3.71 grams of hydrochloric acid. The question being asked is how much magnesium chloride is going to be produced. We do need a balanced equation for this, so I'll write out the blank equation. To balance this out, you're going to need 2 hydrochloric acid. That will give me 2 chlorine. Apparently, I already have that. Then I need to take a look at how much hydrogen. There's 4, so I'll make 4 on the other side, resulting in 2 oxygen, and everything's balanced at this point. Now, for a limiting reactant problem, I need to convert one reactant into the other. There are many ways to do this, but this is probably the best way and what we covered in class. When I do that, I'm going to make sure that I have enough or too little of the reactant that we're converting into. Here, I'm going to convert magnesium hydroxide into hydrochloric acid, and then I'll see how much I actually have. So here's my setup. 1.85 grams of magnesium hydroxide. I set up my dimensional analysis box. I'll cancel grams of magnesium hydroxide. And then I want to convert to moles of magnesium hydroxide. In the next box, I'll cancel moles of magnesium hydroxide. And I'll convert that into moles of the reactant we're looking for, which is hydrochloric acid. Remember, we're not going to go to the product just yet. We don't know which one's going to run out. Hydrochloric acid is my reactant. I'll go ahead and cancel moles of hydrochloric acid. What I'm going to convert hydrochloric acid into will be the grams of hydrochloric acid given to me. Some problems might have liters. I need to make sure the unit matches. Here's my whole dimensional analysis setup. I need to plug in the correct numbers. This is a mole to gram conversion. 1 mole equals the molar mass of magnesium hydroxide. That happens to be around 58.3. This is a mole to mole conversion. That will come from the balanced equation. Here, 2 hydrochloric acid to 1 magnesium hydroxide. And finally, I have a gram to mole conversion for hydrochloric acid. 1 mole equals the molar mass of hydrochloric acid, which is around 36.45 grams. Once I solve for this, this will tell me how much hydrochloric acid I need. Make sure you use order of operations. That's a common mistake that some of y'all are still making. Product of the top divided by product of the bottom. This final answer is around 2.3 grams of hydrochloric acid. That is not a final answer. That just tells me how many grams of hydrochloric acid are necessary for this equation. I currently have 3.71 grams of hydrochloric acid. It doesn't look like I'm going to run out. So that means that hydrochloric acid is not the limiting reactant. By logic, that means the magnesium hydroxide must be the limiting reactant. This is a logic question. Whenever we convert one reactant to another, we need to see if we have enough or too little. This is how we determine the limiting reactant. Now that I know the limiting reactant, I'm going to use the magnesium hydroxide, the limiting reactant, to solve for the remainder of the problem. The actual answer is supposed to be how much magnesium chloride is produced. I'm going to start with the magnesium hydroxide that I now know is a limiting reactant and convert it to the magnesium chloride that's being asked for. This is a regular stoichiometry problem at this point. I'm given 1.85 grams of magnesium hydroxide. I set up my dimensional analysis box again. I'll cancel grams of magnesium hydroxide. And I'll convert it to moles of magnesium hydroxide. I already calculated the molar mass for this. I'll keep going. Moles of magnesium hydroxide get canceled and converted to the reactant, the product we're actually looking for, magnesium chloride. I'll cancel moles of magnesium chloride and convert it to the grams of magnesium chloride that the problem is looking for. My whole equation set up. The only thing I have to do is plug in the right numbers. I know a fair bit of this already. 1 mole of magnesium hydroxide equals a molar mass, which is 58.3. Mole to mole conversion here is easy. Magnesium chloride has a 1, and magnesium hydroxide is also 1. To finish the problem, the only thing I have to do is solve for the magnesium chloride molar mass. I'm going to leave that up to you. At this point, these are problems you should be familiar with, but this is a setup for question number 2 in your practice. Make sure you use order of operations. Product of the top divided by product of the bottom will result in the total grams of magnesium chloride and my final answer. Well, I hope that helps in solving for the remainder limiting reaction problems. Make sure you check to see what final product you're looking for, as well as what reactants you're given. Some of them are using liters. You're not going to always use molar mass. For submitting this work, I would suggest that you either take a picture or possibly get a scanner app. I use Scanner Pro all the time to make a PDF file. It makes my work look a little bit cleaner. I'll be working on another video here for the new content percent composition. I did upload the notes for you all, both in PowerPoint and PDF format. I know that the use of equations sometimes makes the PowerPoints look a little bit weird, especially on mobile devices. Thankfully, percent composition isn't terribly difficult, but it is one smaller step for a bigger problem that we're going to look at in the future. I hope you all have a good week, and if you have any questions, contact me through Canvas, and I wish you all the best.